So with smallest model, fine-tuning is more cost-effective for sure. That's one of the things. You can make a smaller model more of an expert. So what you really want, this is just one part of the solution, is to make your LLM more and more expert around the domain you are trying to run it on. The second piece of it, and it doesn't work without the second piece, is having guardrails outside of LLMs, which are cross-checking. If you are doing, say, coding, having a sandbox environment where you quickly run this code with sample data, is it producing the output? Yes, then you pass it on. These are not very computationally intensive to build or do, but having that safety net right outside, because you have to say that this is a probabilistic model. It will make sudden mistakes, but can we catch them early on and set it back?
It's the nature of the tech, I think. But the other thing is, a smaller model is going to have less total options to give you random probabilities. It's just a smaller number of parameters.
Yes.
And the other thing is, it makes it easier for you to self-host it or host it in a controlled manner, so you don't have to worry about outside influence. And when I say about outside influence, that's not necessarily a negative. Someone could come up with a enhanced and a better model. But what that doesn't mean is you want to go use it in your business use case because it may change the way it responds.
Correct. Yeah.
And so a small model, one of those 3 billion parameter, you can easily host that on something in the cloud or something local that's completely in your infrastructure control. It only changes when you update that piece, not when someone else wants to.
Absolutely. I think, this places where smaller model does really well, and there's spaces where your bigger models need to be there. If you are having things which need multi-model interfaces and things like that, smaller model wouldn't cut it basically, right? So it all depends on what you're trying to do.